Today I am going to discuss a question related to friction and Newton's law. So we will directly go into the question. So the question is, two boxes are stacked side by side on top of a large box as shown. So I will draw the diagram here. So we have a larger box and we have two boxes placed on this box like this way. So you can see the actual picture given in the question in the screen. All three boxes have mass simple length. So all the boxes has the mass simple length. So we will mark the forces. So the weight of this one is I can mark as mg, and this is kept on the ground like this. And mass of this one is m, therefore I can mark the weight of the object as mg. And here the mass is m, therefore the weight of the object is mg. The coefficient of static friction between the left box and the bottom box is mu s. So this is the left box. So the coefficient of friction between these two surfaces is given as mu s. So that is the static friction coefficient. So we will talk about what is static coefficient. All other surfaces are frictionless. So all the other contact points, they do not create any friction. Here no friction. In between these two surfaces no friction. These two surfaces no friction. A rightward force capital F is applied to the bottom box. So a rightward force capital F is applied to the bottom box. What is the minimum value of mu s so that the upper box does not slide? Upper boxes don't slide. Okay, that means, so we have to consider a situation where if I pull this third object on the bottom, so these two objects should remain without slipping on this one, right? So just imagine a situation, a practical situation, what will happen. So when you keep something and what happens if you suddenly pull them, so you have the experience, they will slide not to this side but to the other side. So you can experience it. So you can take a piece of so if I take this one, this is by a book, and I am keeping two objects here like this way. So this is a similar situation like this. So what I do is, now I am going to pull this one. So you see that J just came to the opposite direction of the applied force. So that is because of the inertia. So this question is basically on the inertia and how the friction works. So we will see. So we have marked three forces, the basic three forces, that are the weights of each object, that is always downwards. So now we will go into deep how to mark the other forces on this diagram. So you know here there will be no friction between these two surfaces, there will be no friction between these two surfaces, but you see these two are in contact with each other, and these two are in contact with each other, these two are in contact with each other. That means you know that from the Newton's third law, when there is a contact between two objects, there must be an action and a reaction force. So we will mark those forces. So I will take this object as my first object, this object as my second object, and this one as my third object. So here you don't need to mark all the forces acting on all three bodies, because this question is basically asking about the motion of the two boxes 1 and 2. So you just need to mark the forces of 1 and 2. So here you know that there will be a reaction force from the third box. On the first one we will mark that one as R1, and there will be a reaction force from box 3 on box 2 like this way, that will be R2. So both these will be perpendicular, and there is a contact between these 1 and 2 boxes, so there should be reaction forces. So we will mark that one as N. So the same force will be in this direction N. So this will be perpendicular to the surface. So you see in your diagram that I have given in the question, they all are packed together. This one is touching this one is touching this one. In the drawing also they have been drawn touching each other. But the problem when you draw like that is you are unable to mark the forces clear. So when you have separation between each of these objects like this, so this is not floating, right? So I have just move that up a little bit so that I can mark the forces properly. So you can see here now on this first object there are three forces acting, that is mg, r1 and m. So I can clearly see what are the forces acting on each body separately. So that's why I am drawing these like this. Okay, don't imagine that they are floating in the sky, that's not the case. So that is for our easy marking forces. So this is we call as the free body diagram. So we have marked all the forces. Now we missed one, what? That is the friction, because you know that in the question it is given the surface between 2 and 3 has a friction coefficient mu s. So you see here, if you consider the horizontal forces acting on this one will tend to move to this side. It's natural because there's a force acting to the left side. Therefore, definitely the frictional force will be acting in the opposite direction of the motion. So that will be to this direction. So I will mark that one as simple F. So this red color force is my friction force. Right, now we have marked all the forces. Now we can go for the simplifications. So first of all what I do is, now when a force is applied on a mass, definitely there should be an acceleration according to the Newton's second law. So what we'll do is, first I will consider the whole system, which means all three objects, and I will apply F equals ma in the right hand direction. So better to apply F equals ma in the direction of the force. So let's consider all the forces acting on the total system in the rightward direction. So if you consider all the forces, you see these two forces will be get cancels out. So no effect from these two ends. So only this capital F will be the external force acting on this one. These two will become two internal forces. So we can write capital F, that is equal to the total mass of the system, that is 3m, and I will take the acceleration of the system as a. So the acceleration of the whole system I can write as F divided by 3m. So this is our first answer. Now we have found the acceleration of the system. So why I found the acceleration first? Because when a system is subjected to a force, there should be an acceleration. That's why I first put F equals ma and found the acceleration. Okay, next I will go to this one. So better to use this one because we have only two forces to consider. So here for this object, it is inside the whole system. So if the whole system is accelerating at acceleration a, so this individual object must accelerate at acceleration symbol a. So now what you can do is, now you can apply for one F equals ma in the rightward direction. So here the force acting, now we have to consider only the first one. So if you consider only the first one, the only rightward force is capital A, and mass is simple m, and the acceleration a. So here you can find n is equal to m capital F divided by 3m. So here you can get n is equal to F over 3. Right. Now we have found n also. Now we will move into the third object. So here you have friction. So that is given as static friction. So tell me how we can write static friction. So if you remember the theories, you know that we can write static friction, which is the limiting friction actually, the highest friction that is possible. You can write it as mu s r. So here mu as the friction coefficient, static friction coefficient, and R is the reaction force here. In this case, that is R2. So you can easily find simple F. Simple F is equal to, we just take the expression into R2. Now you have to find R2. So how do we get R2? So this object is moving only horizontally, not moving vertically up or down. That means it should be in a vertical equilibrium. So you can consider the vertical forces acting on second one. So I will consider here for second one, if I apply vertical equilibrium, you can easily get that R2 is equal to mg, because there's no accelerations or no motions in the vertical directions. The only possible motions are in horizontal direction. So R2 is directly mg. Just you can see and just you can write that R2 equals mg. That's easy. Now you can write from this equation, you can get friction. Therefore friction is equal to mu s mg. Right. Now if you consider this mass, now I know almost all the things. I know R2, I know N, I know F. So now I can easily apply F equals ma to the second object. So I am going to apply F equals ma, the second object, F equals ma. So it is also moving with the system, therefore it is moving on the rightward direction. So I have to apply the F equals ma to the moving direction, not to the other direction. You can apply, it's no issue, but it is easy for you to understand if you apply in the motion direction. So we will consider what is the total external force. Here you should put total external force acting on the considering direction. So if you consider here, you have simple F here in the direction that we are considering, and we have capital N in the opposite direction, that is minus capital N. That is equal to, so the mass of the system is simple M, and as a whole this is accelerating with acceleration A, therefore this object also accelerating at the same acceleration, so it is also A. Now you can write then F is equal to N plus ma. Now you can substitute here, the friction force is equal to mu s, we have found this mu s mg, that is equal to N is F over 3 plus mass into acceleration, again F over 3m. So if you simplify this one, you can easily get mu s mg is equal to m cancels out, F over 3 plus F over 3 means 2F over 3. So I will take this one to here. So we can take this mg to the other side. So mu s is equal to 2F divided by 3mg. So this is our final answer. So this is a very easy question, but you have to go step by step. First thing to do is to mark all the forces. That means the free body diagram, it is a must. Without the free body diagram, you cannot understand what's actually happening here. Okay, so this is very simple question, but it seems difficult if you go in the wrong way. So I'll try to understand what is the theory behind this one. So try to learn the application and try to learn the theory behind that one. So this is our question today. So if you have any more questions that we should discuss, so please let us know. So then I can prepare and I can present you that question in a very comprehensive way. So it will be a great support for your examinations. So thank you all for watching me. So let's meet in a new question like this.